So in this lesson, we want to continue our series of teaching on principle of movement. Principle of movement. We started this lesson in our previous class, and today we want to continue from where we stopped. Now, the principle of movement, what does this say? Now, let's look at this beam balance. A beam that balance on support, two support, Q and R. This is a beam balancing on two supports, Q and R. Now, the weight of the body, W, is acting downward. There are forces F1 and F2 that are attached to this end. These supports, Q and R, are acting upward. They are acting upward. They are suspending the beam. While these three forces, the weight of the body, and these two forces are acting downward. Then one of the principle of movement states that the sum of all the upward forces must be equal to the sum of all the downward forces. That means the first one, you have upward forces. These are the two forces that are acting upward. The sum Q plus R supposed to be equal to downward forces. That's F1 plus W plus F2. F1 plus W plus F2. The sum of upward forces must be equal to the sum of downward forces. And the second principle says that clockwise moments must be equal to anti-clockwise moments. Clockwise moments must be equal to anti-clockwise moments. Now, if you are what referred to as clockwise movement, the way the hand of clock move is clockwise. Then the opposite of the way the second hands of clock move is anti-clockwise. Clockwise, that means the second one move like this. Then anti-clockwise will be the opposite of it. That is clockwise movement. If I'm taking moment about this point Q, taking moment about point Q, the sum of all the reaction at a point is equal to 0. That's another principle. The second principle says that the sum of all the reactions, at a point is 0. Sum of all reactions at a point is 0. That is, if I'm taking moment about this point Q, the sum of all the reaction here will be 0. Now, if I'm taking moment about this point Q, clockwise movement, this one move like this, clockwise. This one will go like this, clockwise. And this one will move like this, anti-clockwise. And this R will come like this also, anti-clockwise. So the third principle says that clockwise movement is equal to anti-clockwise movement. Clockwise movement is equal to anti-clockwise movement. Anti-clockwise movement. Now, if you look at our clockwise, these two forces, W and F2, are moving clockwisely. Then the clockwise movement in that case should be equal to, this will time the distance from here to this place. So you have W times D2 plus clockwise, this and this. Then this one too, that will come and move here. The distance from here to here is D1, D4. The distance from here to here is D3. The distance from here to here is D2. The distance from here to here is D4. Distance from here to here is D3. Distance from here to here is D2. Then the total distance from here to this place should be equal to F2 times open bracket D4 plus D3 plus D2. So you need to calculate the distance from here to here, to where you are taking the moment. Then should be equal to, clockwise moment should be equal to anti-clockwise now. This one is going like this. So you have from here to the distance is D1. So you have F1 times D1 plus the second anti-clockwise is this r coming like this. So from here to here is d3, from here to here is d2. So the total distance will be d3 plus d2 plus r multiplied by open bracket d3 plus d2. So these are what the principle of movement states. If you understand this expression as simple as it is like this, if you start solving questions, it will be very easy for you to understand. That's why these principle of movement are very important. But don't be perturbed. We'll bring real-time examples on how to apply this principle of movement with questions with all these forces having value and all these distances having value in our next lesson. So if you are new to our channel, subscribe to our YouTube channel at Physics with Chris for more exciting topics on physics. Bye.